Venus was the first planet beyond Earth ever to be explored by a spacecraft, but its popularity has dropped off in recent years. NASA's Mariner 2 mission, which flew by in 1962, marked the beginning of nearly 3 decades of intensive exploration by the US and the Soviet Union. Between then and 1990, 18 dedicated missions went to our neighboring world, plus several flyby missions with other destinations. The Soviet Union series of Venera missions provided the first landings on another planet, as well as the first images and audio recordings from another planet. But since NASA's Magellan orbiter, which launched in 1989, there have only been 2 dedicated missions to Venus as the spaceflight community's focus has switched to Mars. Now, with DAVINCI and 3 other missions planned for the late 2020s and early 2030s, Venus is coming back into the limelight. The DAVINCI, Deep Atmosphere Venus Investigation of Noble Gases, Chemistry, and Imaging Plus mission, scheduled to launch no earlier than 2029, includes the first probe that will enter Venus' atmosphere since the Soviet Vega 2 lander in 1984. Its main goal is to investigate how the atmosphere formed and evolved over the last 4.6 billion years. That is crucial because Venus' atmosphere played a key role in the process that heated it up. It is incredibly thick and made mostly of carbon dioxide, which caused a runaway greenhouse effect that evaporated away the planet's water. Measuring the composition of the lower atmosphere will help scientists figure out how much water there was in Venus' past and what chemical processes are still at work there. Looking into those chemical processes will also shed light on the issue of whether Venus clouds could be hospitable to life. If DAVINCI confirms that the clouds contain phosphine gas, scientists will have to explain how it got there and whether it is connected to living organisms. The mission will also take high-resolution images of Venus' surface, particularly focusing on features called Tesserae, which are strange, wrinkled landforms that we do not fully understand. If we can figure out how they formed, it will give us insight into the planet's geological activity and how its subsurface workings affect the surface terrain. The mission consists of 2 parts, an orbiter and an atmospheric descent probe. The orbiter will have a camera on board to image the planet in ultraviolet and near-infrared light. It will also take pictures of the descent probe's landing site. The descent probe represents the main thrust of DAVINCI. It is a sphere about a meter across designed to protect the craft's 4 main scientific instruments from the extreme environment within Venus' atmosphere and on the ground. With the help of a parachute to slow it down, it will fall from orbit down to the planet's surface, taking measurements the whole time. Its instruments include 2 spectrometers to determine what compounds make up the atmosphere, a device to measure the structure and dynamics of the air, and a camera to snap photographs as it lands. Once the probe lands, it is only expected to last about 20 minutes on the Venusian surface before being destroyed by the intense heat and pressure.